Hey everyone, welcome back to my channel. This is Rahul. Today we are diving into an awesome problem solving session using Java. The problem word subsets. It's a classic coding challenge and perfect for interviews. By the end of this video, you will not only understand the solution but also why this is a favorite problem in MAANG interviews. Let's get started. Before we dive into the code, let's talk about why this problem is important. This is a problem that frequently shows up in coding interviews at companies like Google, Amazon, and Meta. Why? Because it tests multiple key skills. First of all, string manipulation. Handling character frequencies is a core concept in algorithmic problem solving. Secondly, optimization. You are required to come up with an efficient solution combining constraints from one array into a single representation and using it to evaluate another array. Thirdly, system design thinking. The solution mimics real world problems like search engine filters or inventory matching. So, if you are preparing for MANG level interviews, pay close attention to this problem. It's not just about solving it, but also about explaining your approach clearly. Here we have two lists of words, words 1 and words 2. We want to find all words in A and B and that are universal for B. Universal means that a word from A must contain at least all the letters in all words of B combined. Simple to understand, but solving it efficiently requires some smart trick. So let's get into our code. So here is our word 1 and word 2. I mentioned A and B here. So we are taking two arrays of string as input words 1 and words 2. The goal is to return a list of universal words from words 1. So let's start by initializing the result list to store our output. New array list. Then we have to define an integer array. I will name it as target new int of 26, which represent the frequency of each letter across all words in words 2. Why 26? Why 26? Because there are 26 letters in the English alphabet. Next, we have to write one loop through all the words in words 2. Then we create one temporary array to count the frequency of each letter. So we will use the size 26. Then for each, here is the trick we are using. For every character in the word, we increment its count in temp. Then we update the target array to store the maximum frequency of each letter across all words in words 2. We'll use ch word dot to char array. temp ch minus a plus plus, then target. Okay, equal to, we will update the target array now. Math.max target ch a. Yeah, so we done that first one, first loop. This ensures that target represent the combined requirements for all words in words 2. It's like building a checklist of the minimum letters required for any word to be universal. Next, we will process each word in word 1. For every word in A, we calculate the frequency of each letter in an array called source. For that, we have to create one source. Then, uh, in this one, we will use a helper function. We will define it later. For char, same like before. For dot to char array. Sorry. Source of ch plus a. Yeah. Now we are using the helper function. We are naming it as subset. We will use two parameters, source and target. Result dot add word. Now we have to return the result here. Then we have to define our helper function subset. We will use boolean for that. Private boolean subset. We are using the two arrays, int parent, int child. We will use one loop. Sorry. Here is the logic we are using. Here parent represent the letter frequency of words in words 1 and child represent the letter frequency required for our universality. Here we compare the two arrays letter by letter. If parent has fewer of any letter than child, we return false, otherwise we return true. This ensures the word meets the criteria to be universal. If parent of I less than child of I, nothing, just return false. Else return true. That's it. Let's run it now. It is statement. What's the issue? Yeah, I forgot to give the increment. Yeah, it's working. So let's just recap the solution quickly. First, we computed the maximum data frequencies for words 2 in the target array. Second, for each word in words 1, we calculated its letter frequencies in the source array. Third, using the subset function, we check if the word in words 1 satisfied the requirements of words 2. If it did, we add to the result list. Now let's talk about the efficiency of our solution. The time complexity is big of words 1 into 26 plus words 2 into 26, which simplifies to big of a plus b because 26 is constant, right? This solution is space efficient as well, using array of fixed size instead of hash maps. Why does this matter in a MAANG interview? Because interviewers aren't just looking for a working solution. They want to see your ability to write optimized, scalable code while explaining your thought process clearly. Let's submit it. Yeah, it's working. So, if you are solving this in an interview, think out loud. Explain how you plan to approach the problem before diving into the code. Interviewers want to hear your thought process. Second, highlight edge cases. What happens if words 1 or words 2 is empty? Or if there are duplicate words? Showing awareness of edge case is key. Next is be ready for variance. Interviewers might tweak the problem. For example, they might change the alphabet size. Example, handle Unicode. As for insensitive matching or limit memory usage further, be prepared to adapt your solution. And that's it, our complete solution to the word subsets problem. This is a fantastic question for practicing MANG level coding interviews. So give it a shot yourself. If you found this helpful, don't forget to like this video, subscribe to my channel, and hit the bell icon for more in-depth coding tutorials. Drop a comment if you have questions or want me to cover another tricky problem. Thanks for watching, and I will see you in the next video. Happy coding!